Hello everyone, today we continue exploring MES, Manufacturing Execution System Software. If you've been following the previous episodes carefully, then by now you already know how to work with databases, understand what a peripheral device is, can program microchips, and can create and maintain test stations. All of this knowledge forms an essential foundation, a combination of skills we need to build complex systems for managing production or service processes. In the previous episode, we deployed our MES system, and now I have the GUI running on my computer, so let's gradually break down what, how, and why everything works. To begin with, I'd like to touch on the topic of design and functionality. To make my point clearer, especially for those who prefer colorful icons, buttons, charts, pop-ups, and various GIFs, we actually try not to use these techniques, and here's why. Let me give you an analogy that might be especially clear for women. I'll show you two examples of professional makeup tools. In this picture, you can see that color is not the priority. All the brushes are designed in neutral dark gray tones. Very minimalistic, very functional. And now I'll show you a picture that is probably familiar to almost every woman. This is what we typically have in our personal collection. In this case, we often care more about how things look, and as a result, it ends up being quite messy. Or here is an example for men. Here you can see a well-organized electrical panel, built properly by professionals. And this other one is what an average person might put together. It will probably work as well, but you see the difference. Now I want to draw special attention to this comparison, specifically for men, not women. From a practical point of view, which electrical panel is more appropriate? The white one with colorful breakers and wires, or this black and gray version? Women might say, the white one looks nicer. But men, after thinking it through, will choose the black and gray option. Why does this happen? We can go deeper into this if you're interested, let me know in the comments. The key point is design plays a critically important role across many criteria. For example, when you're developing a program, you might feel the urge to color every button differently based on its importance or significance. And in the end, you get something like this. Or you might want to place everything on a single user interface without using tabs, because it seems so logical for the operator to see everything at once. And as a result, you end up with something like this. Or it's very trendy now to add all kinds of graphs and charts, and in the end you get something like this. And if you noticed, the entire purpose of these user interfaces is simply to display 2 or 3 numbers. Useful numbers, yes, but still just 2 or 3. At the same time, there is no real functionality here. The only goal is to show these numbers. In other words, these are statistical data meant for analysis, but they are not suitable for managing or administering a production or service process. Here I want to point out that in MES systems, statistics certainly exist, but they exist in the form of big data, meaning tables with a wide variety of information. These tables can later be used to generate any kind of statistical reports after development. And as you can imagine, even if we create several tabs with predefined charts, we still won't be able to guess correctly. It's practically impossible to predict what kind of statistics will be needed, in which situations, and for what specific purposes. So, now we understand why we choose a classic conservative design and why we use seemingly uniform buttons and windows. This is done intentionally, so we can focus on the functionality of each element without getting distracted or confused by various graphical icons on buttons, which of course we could easily over-design. Let's move on. To develop an MES, we need to understand the production process for which we are creating it. That is the very first step. To structure the task and translate general knowledge into a program algorithm, we need to create a flowchart. But wait, before creating a flowchart, we should first mentally visualize how everything will work. Even better, we should walk through the production site together with a technician or engineer and sketch something like this. Let's imagine that we visited a cement plant where cement is produced, and we created a diagram like this. From that, we identified and defined the test stations that we will need. First, the unloading stage, then the grinding stage, where the material structure is crushed, and so on. You can see all the stages illustrated in the diagram. Or, for example, let's imagine we walk through a metal production plant, created a similar diagram, and the plant engineer confirmed that everything is correct. They provided proper names for each stage of the production process, often in the form of specific abbreviations, and also described the key parameters that matter at each stage, as well as all the transformations the product undergoes throughout the process. So we have now become familiar with the production process, and we are ready to move on to analysis and to designing the architecture of our future MES. For this, we can create something simpler and similar to a flowchart. For example, something like this. Here we add the connections between the production processes, and in this way we get something that looks almost like a real flowchart. The next thing we need to consider, and this is a very important point in organizing any production process, is the operator's work and the operator's workstation. Depending on many factors, whether it's a workshop, a production line, or a clean room, the operator may be allowed to sit or may need to work standing. We must decide whether a touchscreen display is appropriate or if a button-based interface is better. If a touchscreen, what size should it be? Will it still function properly if the operator is wearing rubber gloves? If there is a separate keyboard, how will it be protected from dust if such conditions exist? And there are many other factors, including labor regulations, fire safety requirements, and various certifications. So, after overcoming all these challenges, we finally get close to creating a flowchart. Let's say we end up with something like this. At first glance, it may seem like we can already start building the architecture of our program and get to work, but that's far from the reality. Now let's quickly, without going too deep, let's go through other important aspects that also need to be taken into account. So, as a developer, I clearly define in my business proposal what exactly I will deliver. First, this will be a program that is installed on the Windows operating system. Second, it will be a standalone application, as you can see noted here, installation for each user's computer as an independent application. Why do we choose this approach? Because there are many different ways a program can be deployed and used. As a web-based application, including SaaS, as a local host installation with or without connection to various servers or databases, as a proprietary license or subscription-based model. We won't go deeper into this right now, it's a separate area of knowledge. For now, we simply chose this option and proposed it as the most optimal solution from our point of view. Of course, our clients may have their own preferences, but we need to be able to stand by our choice. So make sure you have solid arguments prepared. So we chose a local server or a local database. What's the difference? When we talk about a local host database, we mean that there are certain computerized workstations that cannot be connected to a local server. For example, due to confidentiality, lack of wired connection, or when it's impossible to use Wi-Fi or Bluetooth. We should always keep this as an option, because every production environment has some kind of technological secret or constraint. A local server, on the other hand, is a computer that is connected to a local network and hosts everything required to support the production process. Services, databases, and possibly an additional firewall if there is internet access. That's why we propose an option of a remote database with encrypted data transfer. And of course, security. Here we must pay special attention to security. There are many arguments we need to prepare in order to convince the company's IT specialists. This is an area where we must be very thorough and well prepared. So overall, we presented the structure of the software we are developing to the company's management. As you understand, I've only outlined the main topics without going into deep detail. Each of these topics deserves a separate, in-depth discussion. Right now, our goal is to look at the core principles of how MES software is structured without going too deep into specifics. Let's assume that our concept for building and implementing the MES has been approved. We understand that it has been accepted at the level of both company leadership and the IT department. However, for the concept to be fully validated, we need to move to the next level, the managerial, engineering, and operator levels. This is where we must fully apply our understanding of the production process. So now let's take a look at the general functions that our program should include. Here we include functions for receiving, storing, and managing inventory, as well as handling multiple warehouses depending on their physical locations. We also account for personal responsibility for inventory assigned to each user, along with many other features and characteristics. I won't list everything right now, it would be too exhaustive. It's important to understand that each of these functions and additional features will definitely be requested at this stage. Every manager, engineer, or operator will want to add something of their own based on how they believe their work should be organized or optimized. Of course, we try to anticipate as many scenarios as possible, but if we miss something, we should be ready to implement it right away. So instead of going through each point one by one, let's move into the program itself and see how these functions and features are implemented in practice. And once again, I want to emphasize it's not enough for us to convince the company's leadership and the IT department. It's just as important to convince all participants of the future process. Now on the screen you can see our MES software. If you want to know how we deployed it on a computer, watch the previous episode. In that episode, we also covered step by step how you can download it for free and install it on your own computer. When I first launched the program, I log in as an operator. For example, I select the operator Suzanne and enter the password. The login is successful. However, you may encounter an issue. Why? Because the program may return an error saying that there is no connection to the database. To fix this, you need to take ownership of the folder where the program is installed. Why is this necessary? As we discussed earlier, everything installed on the C drive by default has read-only permissions. But since we need write access, because we are working with databases and configuration files, we must grant ourselves full control over that folder by using Take Ownership. How to enable this option in the context menu we covered in the previous episode. So, we have taken control of our program folder and enabled write permissions. This is the same folder where the program is stored, along with the training database. Now we have no restrictions. We can both read from and write to this folder. If you plan to install and connect your own database, it may be located either on your local computer or on a server. In that case, you will need administrator privileges. This will allow you to configure the database path, set up the OLEDB connection, and define your database credentials. We won't go into that right now. If you run into any issues, feel free to write your questions in the comments. So let's start working with our MES software. Let's take a look at what permissions Suzanne has. As you can see, the user interface is simplified as much as possible, with a minimal number of windows. On the left side, in the left tab, we see the login section. Credentials, meaning the operator's username and password. We also see a messenger. This is an internal system messenger that works through global variables. It is not connected to any public or well-known messaging platforms. It is strictly internal and allows communication only between users of this system. No one outside the system can access or see these messages. All messages are stored in our database in dedicated tables. Later, we will see small notification windows that indicate whether there are unread messages, who they are from, and whether a response is needed. We'll come back to that. For now, let's focus on understanding the login process. So, to log in to the system, we need a password. In a moment, we'll go to the tab where we configure credentials, username and password. But first, let's see how the system reacts to an incorrect password. I enter wrong password in the login field and we see an error window, wrong password. Now I enter the correct password and the login is successful. The available options are now unlocked. Let's take a look at what capabilities are assigned to Suzanne. In the Work Options section, we see two delegated permissions, Structure and DB database query. This means that Suzanne's role in the manufacturing execution process is relatively focused. She can work with the company structure and execute SQL queries. However, we cannot say that her permissions are minor. The ability to send SQL commands to the database indicates a high level of trust, since she can directly modify the state of the database. Now let's look at the tools available to her in database functions. She can create tables, modify existing tables by selecting which one. She can delete tables, edit cell values, delete rows, and even send direct SQL commands. If you've been following our episodes, you know that we dedicated an entire section, a full playlist to this, so you already understand how all of this works, both on the programming level and on the user level. We'll come back to this later. Later we will actually work in the system as a database operator. We will perform these functions and see how everything works in practice. For now, our goal is to understand the structure of our MES software. The second function that the company has delegated to Suzanne is working with the company structure. Let's take a look at what we have here. This is the structure list. What do we see? It's essentially a list of the company structure. In this context, structure refers to the relationships between warehouses, suppliers, customers, and employees. Where this structure list comes from and how it is formed, we will cover that later. To make working with each table easier, the system provides pop-up windows that help to navigate the process. This significantly simplifies working with the data. For example, I select the vendors table. Let's assume this is a large table, not just 3 rows like here. And I want to find the vendor by address, because I don't remember the name. I type the address into the table search field and select the address column. In this case, I get 4 matching rows. I select one of them and can modify it, update it, or create a new entry. For example, let's change the city to San Jose and save it. I can also create a new record. Let's say there is another company at the same address. I enter the data and save it. The program notifies me that a new record is being created. I confirm, and the new entry is added to the table. Well, that was quite straightforward. We can say that Suzanne has mastered the functions that were delegated to her within the MES software. Now let's switch to another system user and see what permissions they have. Let's log in as Bill. What do we see? Bill has similar capabilities to Suzanne, but in addition to structure and database query, he has an additional, much wider set of functions. His task options are also more extensive. Let's take a look, for example, at his operation permissions. Here we see that currently no operation exists. That means no specific operational tasks or workflows have been assigned to him yet. Also, no additional program interactions are configured for him at this point. What we do see is a standard operator interface where the operator is expected to enter required values and submit them to the system. We also notice that the operator is limited by time when entering this data. However, since Bill's specific table or workstation has not yet been set up, meaning his role in the system is not fully configured, there isn't much for him to do here yet. That said, we can see that Bill has many other interesting functions and tasks available. We will explore all of them in the next episode. We'll also dive deeper into MES, its applications, variety, capabilities, and much more. And that's all I've got for today. Thank you for joining Laplanda Tech. If you have any questions, please leave them in the comments. If you learned something new today, give this video a like and subscribe to learn more from upcoming episodes.